Welcome to part 1 of the TackleBox hook management walkthrough. In this brief video, we will be running a ResNet 18 on CFAR 100 using Torch Vision. Please consult the requirements.txt file for the full list of notebook dependencies. To start, we will load a batch of data X and load our ResNet. Before we can start working with hooks, we need to import and initialize the hook manager. Next, we will define a simple forward hook that prints the shape of the module output. The arguments of a forward hook are module, inputs, and outputs. Because outputs will be passed as a tuple of output tensors, we will unpack the first output before printing its shape. Now let's register our forward hook on the first conv layer of the ResNet. To do this, we'll pass our hook function to the register forward hook method and use the hook function name keyword argument to assign our hook function an ID. We'll assign it the ID printShape. We pass the modules we want to hook as keyword arguments indexed by a chosen module ID. We'll give our conv layer the ID myconv. We can now look up our registered hook function using the name to hook function dictionary, indexing with our chosen ID printShape. We can similarly look up our conv layer in the name to modules dictionary, indexing with our chosen module ID myconv. Lastly, we can look up the hook handle in the name to hook handle dictionary, indexing with the hook function and module IDs, combined using the bracket syntax. Note that the return displays the handle ID, the corresponding module ID, and whether or not this hook is currently active. Let's now register our hook on the first set of residual blocks in the ResNet. Since our hook has been previously given an ID, we no longer need to pass an argument to hook function name. We assign this module the ID myLayer. Newly registered hooks are activated by default. To register a hook without activating it immediately, we pass activate equals false. Now we can look up myLayer and the new handle that was just created in the hook manager dictionaries. We see that the handle corresponding to myLayer displays as inactive, since myLayer was registered without immediate activation. We can see all handles registered by a particular hook function through the handles property. Let's look up printShape's hook function again and access its list of handles. Now let's test our forward hooks by running the model. We see that only the active hook on myconv was called and subsequently printed output. Once hooks are registered, we can activate and deactivate them. To start, we'll activate all hooks registered to our module myLayer. We do this by calling activate module hooks by name and passing the module's ID. Notice that we've successfully activated our previously inactive hook function. Before the next step, we will deactivate all hooks. We'll now introduce hook contexts, which make activating and deactivating hooks even easier. To demonstrate, we will create a context within which hooks registered to myLayer are active. We use the method hookModuleContextByName, again passing the ID myLayer. Note that the hook is called when the forward pass occurs inside the context, but not outside of it. Contexts are great, but can add excessive indentation. TackleBox context objects extend the add operation for this reason, allowing merging of multiple contexts in the same with statement. Let's create a context to activate all hooks using the hookAllContext method and merge it with torch.nograd for a single line with statement. We successfully activated both registered hooks and confirmed that gradient was successfully disabled. This concludes the hook management walkthrough. In part 2, we will go over forward prehooks, backward hooks, and filtering activation and deactivation by hook type. Thanks for watching.